Okay, so today's date. Oh, it's Valentine's Day, yeah. Our objective is to simplify square roots. Okay. If you take higher math, if you're going to take math, pre-calculus, calculus, and beyond, we have this little thing where we simplify square roots. And there's a reason why we simplify square roots, because we always want to make something better, smaller. We want to try and take math and simplify. Does that make sense? So if I take a look, for instance, like the square root of 18, that's an ugly decimal number. Square root of 18 is like 4.242640687, blah, 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 blah. This decimal never ends. This decimal goes on forever and ever and ever. My calculator is only this big, right? This number goes on forever. This is an irrational number. We call it irrational. Okay? You guys ever heard the word irrational? Irrational, like crazy, you irrational person, or an irrational number because it goes on forever, has no pattern. This is an irrational number. So we don't want irrational numbers. We want nice numbers, okay? So that, the square root of 18, is an irrational number. But what I can do is find a rational number in my square root of 18. So what I want just to do is list. Oh, let's list some numbers that we know. All right, let's see if I can find a pair of. So let's list these numbers here. Okay, so square root of 4, square root of 9, square root of 16, square root of 25. I'm sorry, Natalie. I don't make the rules. I wish I did, but I don't make the rules. Square root of 36, square root of 49. Let's see, what's that? 80, 64. What's the next number? You guys know what I'm talking? You know what numbers I'm writing down here? What's the next number? 81. And then what? And then what? You know the next one? 121. 144. 169. Let's see, 208. What is it? 14 times 14? 196. Thanks, Ava. And then probably 225, right? I think that's all the further we have to go is 225, okay? What makes these numbers so special? I think you already know, right? I think you already know what makes these numbers so special. Well, let's write them down, okay? My guess is if I said thumbs up, probably half of you know what these numbers are. Okay, give me a thumbs up if you know what these numbers are. These are called perfect squares. Perfect squares because if you don't know what these numbers are all about, what is the square root of 4? Square root of 9? Square root of 16? Square root of 25? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. With the square root of 18? Square root of 18? Nah, that's an ugly number. We're just going to call it an ugly number. It's irrational, okay? These are nice numbers because we can take the square roots of them and get a rational number, okay? So we take a look at the square root of 18. We want to reduce this. So what I'm going to do is ask you an easy question. Think of two numbers. What times what makes 18? Think of two numbers. What times what makes 18? 3 times 6. 3 times 6 is great, except for 3 is an irrational number, and 6 is an irrational number. That's totally right. So let's take a look at this. Thank you, Scott. It's going to page you any better than I've already paged you, huh? Well said. So the problem with the square root of 6, ugly number, and the square root of 3, ugly number, irrational. But what if we instead said we want to make it the square root of 9 times the square root of 2? Why is that a better combination?
Because those are perfect squares.
This one is, right? Now 2 is still is not, but the 3 is definitely a perfect square, okay? So I can take the square root of 9. What is the square root of 9? 3. So I get 3, regular 3, not square, but regular 3 square roots of 2. Okay, great, thank you. Oh, gotcha, thank you. Okay, all right. That's it. Now, we haven't changed the value of it at all. We still have 3 square roots of 2. It's still the exact same answer as the square root of 18, but it's reduced. which makes it easier for us to do some things with it later, okay? All right, let me keep going. Camille, here you go. Yeah, here, I'll grab that. All right, let's take a look at number 2. So number 2, this 3 right here, that's a regular whole number. It's not a square root. The 3 is just a 3. So it is part of the problem, but I don't need to worry about it because it's a regular 3. It is not a square root of 3. It's just a 3. So I'm going to write it down, and I'm going to deal with it in a second, okay? But now the square root of 20 is a ugly number. It's an irrational number. So but what it can do is what times what makes 20. And I want to use one of these numbers, don't I? Right? Got it. Heard. I say it again.
5 times 4.
Heard. 5 times 4 is exactly right. But I'm going to write it differently. Totally right. I like to write it 4 times 5 because I like to put the square, perfect square first. But Grace, totally right. Everybody agree with that? Why did Grace say 5 times 4? Because she recognized you can take the square root of 4, right? Which is a 2, a plain old 2, 3. And that's a times 2, square root of 5, okay? And now it's a whole number times a whole number. 3 times 2 is 6. Square root of 5. The square root of 5 you cannot do anything with. It's just the square root of 5. It's irrational, so we leave it. And here's another easy question. Easy question, okay? Easy question. Would you rather have this number on your paper or this number? Yeah, right? That number, right? And not only that, but this is exactly the answer. Square root of 5. This is not exactly the answer because... So our goal, we're going to have square roots probably in our answer. We will, but we want to make them as little as possible. Okay, I'll say that again. So our goal is to get it down as much as we can. We will still have square roots in our answer, but the littlest one as possible. Okay? You with me? Now, before I do number 3, let me ask an easy question. X to the 3rd times x to the 3rd. X to the 5th times x to the 5th. X to the 6th times x to the 6th. Okay, real quick, before I go any further. X to the 3rd times x to the 3rd equals what? Good, I agree. X5, X5. Good, I agree. X6, X6. Agree. So something times something equals. So if I take the square root of x to the 6, what do you think the answer would be?
X to the 3rd.
It's it. It's x to the 3rd. It's just x to the 3rd. Okay? Square root of x to the 10 is what? It's just x to the 5th. Because it's something times something. And then x to the 6. So when I get an exponent, we're going to take half its exponent, half its exponent, half it. Okay, so I'm going to write that down. So on example 3, I have, in a sense, 3 questions. Square root of 4, square root of 3, and the square root of x to the 12. The 12 was a whole number, and I needed one of these numbers. 2 and 6 would not be a very good choice for 12. 2 and 6 would not be a very good choice for 12 because there's no square root of 2 and no square root of 6. But the square root of 4, I can take the square root of 4, and the square root of 4 is 2. With my exponents, let's write ourselves a note. Exponents, take half. Take half the exponent. So we're going to make this x to the 6th. So anytime I take a square root, it comes out. Anytime I take a square root, it comes out. Square root of 4 is 2. It's out. It's out for. Anytime I take the square root of half this, it comes out. See how it comes out? We could do 3, right? Let me try it. It's an ugly number. So we can look at it. And let's keep looking at this. Have you seen this stuff before? Probably not. Probably not. Okay, example 4 looks a little bit harder, but I think if I just do it step by step, the 2x squared is already out. When I say out, it's not inside a square root, right? The 2x squared is already out, so I'm just going to write it down. It's part of the question, but I don't have to deal with it yet. I will deal with it when things come out. Now, what about 27? What times what? Say it?
3 times 9.
Awesome. And I'm going to go 9 times 3. We're saying the same thing. Good. And I will take half of this. I will. Hi, Carly. I will take half of it. So now let's do this. Okay, square root of 9 is 3. Half of the x to the 8 makes that x to the 4. All right, so let's see what's left over. So I've got some things left over, don't I? So x8 is right there. x4, I took half of it. Square root of 9 is 3, it's right there. Now this 2x squared is still part of the question, isn't it? I'm just going to bring it down and put it here, okay? This square root of 3, the square root of 3 is ugly number. So I'm going to leave it as a square root of 3, okay? And the last thing I'll do is tidy this up. When I say tidy things up, I'll just combine the terms that go together. So I'm going to tidy up by, simplifying this like we did last week. So I'll get a 6, 2 times 3, x to the 6th square root of 3. And that is my simplified answer. Okay? All right, example 5. If you don't have an even number, because you can't take half of it. I want to take half of this, but then I get a 3.5, and I don't want a 3.5. So what we're going to do is take 1 away. We're going to make it even. We're going to make the exponent, the exponent even. All right. So I'm going to go and make it a square root of x to the 6th and a square root of x to the 1. Okay, you don't need the 1 there, but I'm going to put it there anyway, okay? So what I did was this. I want to take half of it. I don't want a decimal. I want to take half of it, right? You can't take half of 7 without getting a decimal. Does that make sense? So if I take 1 away, then I get a 6. I can take half of that. So what's half of 6? 3. X to the 3rd, right? So x to the 3rd comes out. When you take the root of it, it comes out. I get an x to the 3, it's out, and then the square root of x is just the square root of x. Because we don't know what x is, we can't take half of it, we are done. Question? Any questions? Okay. Example 6. All right, I got some work to do. So on example 6, it's like looking at 3 different problems. It really is. The first part is this 3x cubed. It's done. It's outside. Leave it alone. We're going to come back to it, okay? This 3x cubed is out of the x squared, so just write it down. 24. What times what makes 24? Good. 4 and 6. Not 2 and 12. 4 and 6. Awesome. Square root of 4, square root of 6, okay? X to the 7th. What do we do over here with x to the 7th? Remember, we're going to do the same thing. We need to be able to take half of it. So we want to make it an even number. So I take 1 of it, make an x to the 6th, and a square root of x to the 1, okay? Well, now let's take some square roots. The 3x to the cube is done. It's already outside, so we leave it outside. Square root of x to the 4th. Square root of x to the 4th. Square root of 4 is 2. The square root of 6, and I can't do anything. Square root of 6 is just an ugly number. Square root of 6, ugly number. Leave it alone. Leave it alone. I'm going to take half of that, right? Half the exponent is going to make a x to the 3rd. And the square root of x, I can't do anything with square root of x, so it stays as a square root of x. Okay, now, I'm just going to tidy things up. I really am. I see a 3 times 2 is a 6. I see an x cubed, and an x cubed makes an x to the 6th. Combine those. And then these two are both square roots. Square root of 6, square root of x, we're just going to write square root of 6x. Okay?
you go. All right. Tell me when you're ready for me to turn the page. All right, let's turn the page. All right, now, 7. So, looks like I need to multiply. I've got the parentheses. Looks like I need to multiply, so let's multiply. I'm going to multiply whole numbers with whole numbers, square root numbers with square root numbers. So I'm going to get a 6 square roots of 18. You guys okay with that? But we're not done. What do you know about 18? It's a square root. What do you know about 18? What times what makes 18?
It's an ugly number. Oh, wait.
It is an ugly number. We can probably find a good number in it. Is there a good number in it?
Yeah.
Yes, 9 and, there you go, so let's rewrite it. The 6 is a whole number, write it down. 6 is a whole number, write it down. But the square root of 9 times square root of 2 will get at least, we'll still have an ugly number, right, Scott? But we'll get at least some of the ugly number out. So the square root of 9, it's like saying there's a beautiful number inside that needs to get out. Square root of 9 is 3, so the beautiful number got out. We'll just call it a rational number. 6 times 3 is 18 times the square root of 2, and the square root of 2 is an ugly number. We're going to leave it be, okay? All right, example 8. Same thing. Same thing, right? Whole number to whole number. Let's multiply, and I get a 15. 10 times 5, square root of 10, square root of 5 makes the square root of 50, okay? Is there a beautiful number hiding in 50? Yeah. What is it? 25, right? 25 and 2, square root of 25, square root of 2, right? And the square root of 25 becomes 5, so we get a beautiful number out. We just call it a rational number, but I don't care what you call it. And an ugly number, or an irrational number, right? Now I've got 2 rational numbers, 2 beautiful numbers, 75, square roots of 2. How am I doing?
So good.
All right, let's do the big ugly one. This is the big ugly one. We can do it. Multiply. So 2x times 4x makes an 8x squared. 2x times 4x, 8x squared, okay? Then let's multiply the square roots. I've got a square root of 18 x to the 4th. Now, square root of 18 is an ugly number. Is there a beautiful number hiding inside of it?
Yeah.
What is it? 9, right? So 8x squared times the square root of 9 times the square root of 2. And I may as well just right now take half of that. I can take half of that, right? Half of that makes an x to the 2. So when I do the process, this is something some kids miss, but when I do this process of taking half of it, it comes out. Does that make sense? The whole idea is to get things out of the square root. You want to get them out. So I took half of it, it came out. Okay, now I'm going to tidy this up. That comes with 3, right? Comes with 3. Square root of 9 is 3. Square root of 9 is 3. And let's see what I have. Okay, whole number. 8 times 3 is 24. I got an x squared with an x squared. We did this already last week. X squared with x squared makes x to the 4th. And then the square root of 2. That's the only ugly number or irrational number, so it just goes there. Okay, now square roots are like x's and y's. You can only add the ones that are the same. So I'm going to write this up here, but I'm going to add these 2. So I'm going to have 5 square root of 2, okay? I'm just going to add these 2. I'm not going to add this one because it's different. That's all. We're just going to add those 2. So I'm going to write that up there. Only add the same, so add like terms. Add same roots. So I'm going to add these 2. Square root of 3. Square root of 3 makes 5 square roots of 3, because there's 2 of them, and 3 more. 5 square roots of 3 plus 4 square roots of 5. And that's all you can do. These are different. You cannot add them unless they're different, okay? That wasn't too hard, was it? Only add or subtract. You can multiply anything. You can multiply anything, but you can only add the things that are the same. Now, if I look at example 11, Sure looks like I'm done, right? Different, different, different. But there might be some beautiful numbers hiding in here. Might be a beautiful number hiding in here. There might be a beautiful number hiding here. Let's check it out. So if I look at 12, square root of 12, is there a beautiful number hiding inside of 12? Yeah, so we have a square root of 4 and a square root of 3, so we can take out a square root of 4. How about 27? Is there a perfect square in 27? 9 and 3. How about 75? Is there a perfect square in 75? 25 and 3. All right, let's keep simplifying, because this is a great example to show you why we simplify. Square root of 4 is 2, so I'll have a 2 times another 2, square root of 3. 4, what's square root of 9? Plus 5. The square root of 25 is 5 square root of 3. Okay, I'll slow down for a second. Okay, so we found our perfect squares hiding in our irrationals. We took the square roots of, now I can simplify this. I'll get 4 square roots of 3 plus 12 square roots of 3 plus 25 square roots of 3. Now, can I add them now? Sure, I can add them, right? Because they're the same. So let's see, 4 plus that's 16. What's 16 plus 25? I don't know. 16 plus 25 is 41 square roots of 3. All right. What do you think? It's not that bad? I used to teach this to my freshman algebra class a long time ago. So if my freshman algebra way back in the day could do it, you guys can do this, huh?